Hello everybody, my name is Chris Lee from Electrical Engineering at Fontys University. I specialise in sensor technology and the development of new devices. What I want to do is I want to change the way that e-bikes are made and make them more efficient and cheaper and more available to as many people as possible. And to do that, we need to develop an entirely new way of powering e-bikes. Okay, so e-bikes currently come in basically two forms. One of them is that the motor is attached to the crank where you pedal, and that has the advantage that you can use existing motors. They have a high rate of turn, so they spin fast, and then you get the torque, so the power comes from the gearbox, so from the fact that you have a big ring at the front and a small ring at the back, and then you get your torque. The other option is to put the motor inside the hub of the wheel. And then you can direct drive what you're doing, but the problem is that the motor is still small, so it takes lots and lots of current to drive it. And in both cases you have inefficiencies due to, in one case, the transmission system, and in the other case due to the fact that you need this high current and high resistive losses. We want to solve that by making the motor much bigger in diameter, by placing all of the motor parts on the outside of the wheel. So then you have a large amount of torque with a high rate of rotation and a low current, which means you have low resistive losses and hopefully a higher efficiency. Okay, so within this proposal, we are working with a company called ID Bike. They manufacture sensors and control systems, and they integrate the production of e-bikes for major manufacturers. We're still searching for other partners as well, I should mention. So in particular, we would like to find a manufacturer that's specialized in manufacturing the motor systems for e-bikes to partner with. If we win this grant, then in the next year we will complete the consortium, so we're going to find more partners. But in particular, we expect to have a proof of principle working within the next 6 months. And within the next year, I think we can have a rideable bike, although perhaps not one that you would want to purchase just yet. And in 5 years, we hope it's on the market for you to purchase. Okay, so currently what we have a group of 6 third-year engineering students working on the project. They're doing what is called the Be Creative minor. This is a minor that is purely project-based. So after the first week of introduction, they work full-time on a project and they bring their own creativity, their own ideas to the project. So the original concept that I gave to them is one that they have now remade into something that is even better, I must say. So I'm very happy with what they've done so far. Their goal is at the end of the semester, so that's 20 weeks, they have a working proof of principle of the motor, they have a good model of it, and they know what the efficiencies are and if there are difficult points in the manufacturing, where they need to be solved or how they need to be solved.